So dear students, you can see the first question. It is given the bulk modulus of a liquid is given. Okay, and it is telling that what is the pressure required to change the volume of a liquid by a value of 2%. Can anyone try this? Take 30-second time and try this. Remember, I give you one hint. You know the formula of bulk modulus. You know the formula of bulk modulus. What is the formula of bulk modulus? It is equal to what? It is delta P by delta V by V with a minus sign. You know this. Delta P, you know this. Okay, now try this. And you all know, you know this formula. Try this. Take. Okay, try this. Try this. Yes, you are thinking right. You know this delta V by V, this term, this delta V by V that we are seeing here, this denominator term, this term. Okay, I think some net issues are there. Okay, this term delta V by V, it is what? It is a fractional change of volume. This is a fractional change in volume. Fractional change in volume. And this fractional change is given in the question. You can see here. Okay, now if this fractional change is given, how can we use this formula? Can anyone apply this formula now? Apply this formula. See, now the bulk modulus, the bulk modulus as we know, the bulk modulus is given. Now what is the value of the, that is, it is telling that the volume is reducing by 2%. That means delta B V by V, delta V by V, it is okay. Please wait, have patience. Okay, now what we can do, see here, what we can do, that delta V by V is given as point, that is 2%. That is, we can write it like this, 0.02. Now what we can do here, see what we can do, the fractional change in volume is given, that is delta V by V, it is given as 0.02. How have written this? What we can see here, see what it is given as, the bulk modulus is given. Okay, and we know that the bulk modulus B is given as, now dear students, let us see. We know that the bulk modulus is given as minus delta P by delta V by V. This we know, all know. Okay, now it is given as the volume reduces by 2%. That means delta V by V, it is given as 2%. That means we can write it like this, 0.02. Now see here, bulk modulus is also given, delta B by V, that is the fractional change in the volume, is also given. So from these two data, we can find the pressure decrement or decrease in the pressure. Okay, so dear friends, take 30-second time and do this calculation and find the answer. Dear friends, please try this question. Delta P, it will be how much? You can see it will be equal to bulk modulus into the fractional change of volume, that is 0.02. Okay, and this will be with a negative sign, because we know delta B by V, it is decreasing, so it will come with a negative sign, and negative will become positive, and we will get how much? That means bulk modulus C here, it is given as 3 into 10 to the power 10 into, we can write like this here, 2 into 10 to the power minus 2. If you solve it, what we'll get? We'll get 6 into 10 to the power 8. You can see. So C is our answer. Any issues, any problem to anyone? We can go through it once. Okay, you can take the screenshot. Okay, now let's move to a second question. Okay, so please try now second question. Okay, now dear students, let us go through this question, assertion and reasoning type question. Okay, please go through the question once, read it. It is telling that, you can see here. Okay, now it is telling that, see here, in a uniform magnetic field, the speed and the energy remains the same for a moving charge. You know, if a charge is moving like this, okay, with a velocity v, we know the Lorentz force that acts on it, and if there the magnetic field present here, so let us suppose B, okay, and we know that the Lorentz force is Q V cross B. This we know, okay. Now this is the assertion. It is telling that when a charge moves in a uniform magnetic field, then speed and the energy will remain same. Reason is what? The moving charge particles experience the magnetic force perpendicular to its direction of motion. Okay. Now I give you 30-second time. Please think something upon it. Please think. Please go through the question. Please try this. Try. You should try the question. It's a very good question. Okay. Very conceptual question also. Okay. So now let us discuss the question. You know, the force is coming when we are taking the cross product of velocity and the magnetic field. So we can say that the result of this cross product is what? It is force. And we can say that the force is a vector which is perpendicular to velocity and magnetic field. So we can say that force is perpendicular to velocity. So we know that from the concept of vector, that is, if a vector is perpendicular to another vector, that means it doesn't have any component on that in that direction because they are mutually perpendicular. So we can say that force cannot affect velocity. Force will not affect who? Velocity. This thing we came to know, that is, it will not affect the velocity, that is speed. Okay. Now let's discuss about the energy. For the energy, we can say like this. We know that one thing, that work done. For the energy, we'll discuss in terms of work done. We know that the work done is what? It is force into displacement. We know that force is mutually perpendicular with velocity. So we can say that force is also mutually perpendicular to distance traveled, that is the displacement. So we can say that if they are mutually perpendicular, then work done will be how much? It will be equal to 0 because they became orthogonal vector. So we can say that if a charge is moving in a uniform magnetic field, then force will not affect the velocity, and also force will not do any work. That is, none of the energy will be stored. That is, the original energy of the charge will remain constant. Got it? So we can say that the assertion is right. The assertion is right. But the reason, see, the reason is absolutely right. Why? Because the reason is telling that the force is perpendicular to the magnetic field. That's why velocity became perpendicular to force, and also the force became perpendicular to displacement. So both assertion and reason are right, and also the reason is a correct explanation of the assertion. So our answer is A. Got it or have any problem? We can discuss it once more. Okay. So now let's move to other question. Now try this question. See, it is telling that I'm just explaining the question. You have to you have try it once. Okay. It is telling that the two identical cell EMF is given. See, they are connected in parallel. Let us draw according to a question. It's telling that EMF is given. Okay, and it is also telling that two identical cell. Okay, let us draw two identical cell like this. Okay, each identical cell has the EMF of 1.5 volt. Okay, 1.5 volt. Okay, now it is also telling that the combination is connected to two resistors of resistance 20 ohm. So we can say that they are connected to wait they are connected to two resistance of each 20 ohm. Okay, now we can say they are connected to two resistance each of 20 ohm. We are not completing the circuit because let us read the question first, then we complete the circuit. A voltmeter is connected in the circuit and measures 1.2 volt. Okay, the internal resistance of the cell is also given. So let us draw the internal resistance of the cell. See here, internal resistance of the cell. Okay, since the cell is identical, we can write it is R and this also as R. Okay, they are connected like this and they are connected like this. Okay, it is also telling that a voltmeter is also connected. So what the voltmeter will read? Voltmeter will read this voltage. Okay, this voltage. Okay, now this is what the question I have drawn for you. Now take 30-second time and try this question. Take 30-second time and try this question once. Try this question. Take 30-second time and try this question. First of all, what you should do, you should take the equivalent of the two cell. Draw the equivalent of this two cell. Okay, how you can draw? You see, how you will draw? You see, you know, if two cell are in parallel, we know that the equivalent cell will have the same EMF, that is 1.5 volt, like this, and the internal resistance of the equivalent cell becomes how much? It becomes R by 2. This we know, and they are connected with two resistance of same value, 20 ohm and 20 ohm. So we can write their equivalent as 10 ohm because two resistance in parallel, we can write it as 10 ohm. So here it is written as 10 ohm. Okay, now what we can say like that, here we know that current will flow like this here. Okay, one more thing we can say here. See, one more thing we can tell here, that you can see here, one more thing we can tell here. See what we can tell, this voltage, we can write this voltage like this. What is this voltage? If suppose current I flows through the circuit, like this, we can write what is V? V is equal to EMF minus internal resistance into current, like this. We can write 1.5 minus I into what is internal resistance value? R by 2, and this voltage is given as, I think, 1.2. See here, 1.2. Okay, from here we got the first equation. Okay, this was from the given data. Now second question we can equation we can get from here. See here, in this circuit, if current I is flowing, we can write like this: I is equal to total EMF 1.5 by 10 plus R by 2, like this. See here. Okay, this is equation 1. This is equation 2. Use this equation, 2 variable, 2 equation. Solve this question, you will get your answer. But I think you will take some time for solving this question because you will solve using such method. Smart method. What will you use? Smart method. Smart method. What you will do? You should do like this. See, smartly how you will do. Take. You find the value of I into r by 2 from here. You find the value of I into r by 2 from here. Okay. Just multiply here. Just multiply here and put the value. You can write like this. See, I into r by 2. You can write like this. It will be equal to 0.3. Okay, it will be equal to 0.3. Now, if you will multiply here, what you will get? You will get 10i, okay, plus I into r by 2 is equal to 1.5. Okay, so we can write like this here. Okay. Once. Okay. Okay. 1.5. Now, what you will do? Put the value of I into r by 2 from here in this equation here, and you can find the value of I. And I think after solving this, you will get, put I into r by 2 from here, put it here, and you will get I, you will put here, okay, you can find the value of I, okay. After finding the value of I, you just put it here, the value of I here, you will get the value of your R, and you will get the value of R as like this. How much? 5 ohm. Okay, so C will be your answer. Got it? Any problem from anyone? You can discuss it once more. Any problem? Anyone? Okay, any problem to anyone? Okay, now remember, this type of question usually comes in your exam. Okay, you should know the combination of the cell, okay, and you should know the shortcut and tricks how to solve the combination of resistor. Okay, for that you can go through the notes. Now let's move further and go through the next question. Okay, okay, now okay, it is telling that identify the pair of physical quantity which have different dimensions. Can you see here what the JEE papers are doing? They are asking the questions which has not been asked from so long time. You can see this type of question usually comes in very 80s, 90s like that, and they are nowadays asking that type of question which has not been asked in previous 10 years, 15 years. Okay, so I think JEE people are just searching the areas where they are not asking the questions from a long time. Okay, so you should also take care of this. Okay, now try this. It is telling that which have the different dimensions. For this, you should remember the basic formulas of this terms, physical quantity, what they are doing given. Okay, so take your time, 10 to 15 seconds. Just go through it, find the answer, or if you know you're having any shortcut, you can go through it also. So take your time. Take your time. Don't bother. These questions are very easy. Okay. Okay. Now let us discuss. Okay. First of all, we should take check here. It is given that which is a different dimension. Okay, wave number and the Rydberg constant. You know the wave number and the Rydberg constant. How can you remember this? Okay, now for this type of question, you should do like this. You see, you remember, you see like this. You know, Rydberg constant. Rydberg constant is what? Rydberg constant is having some value. You know, 10 point something value, 10 to the power 7 like that, meter inverse. Remember that? Okay, and similarly, wave number is also having the unit of 1 by lambda, that is meter inverse. You usually write like this: Rydberg value 1 by lambda is written as wave number. Okay, and the wave number unit is same as the unit of Rydberg constant. So we can write like this, that wave number and the Rydberg constant have the same dimension. Now, if they are having the same dimension, so we can say they are having the same dimension. Now let's go to the next option. Okay, it is telling that you see here stress and the coefficient of viscosity. Now stress, you know, stress, it is sigma is equal to force by. So here we came to know that option A cannot be your answer. It is same dimension. Second, stress means force by area. Okay, and so we can write like this: force by area, that is Newton per meter squared, like that. We know all those things. Okay, coefficient of elasticity, what is it? It is ratio of stress by strain. And you remember, my dear friends, that the dimension or unit of the stress, that is strain, it is dimensionless. You see here, it is dimensionless. M0, L0, T0. That means we can say here the dimension of K, that is the modulus of elasticity or coefficient of elasticity, is same as the dimension of stress. So it is also same. So it is not our answer. C option, positivity and magnetization. You remember, these are also same. Now option D, it is specific heat capacity and latent heat. Okay, you know, Q is equal to ms delta T, and also one formula is Q is equal to M into L. This is latent heat and this is specific heat capacity. If you go to the formula, S will be how much? Q by M into delta T, but L will be how much? Q by M. So we can see here the dimension of S, that is specific heat capacity, and dimension of latent heat will be different. Got it? So dimension will be different for these two physical quantity. Any problem to anyone, you can discuss it once more. These questions are very important because I think we have gone through all those values, all concepts of physics. So I think these questions are very much important. Okay, usually what people do, they skip this type of question. That's why they are asking this type of question. Okay, got it? Let's move. Okay, now let's go to our next question. Now this question. Okay. Now it is telling that a projectile, see here, it is telling that a projectile, okay, is projected with velocity of 25 meter per second, like this, with an angle of theta. Okay, after t second, its inclination with the horizontal becomes 0. And you remember, my dear friends, you remember this, that if a projectile is moving like this, how is the trajectory of the projectile? The trajectory of the projectile is defined like this. Okay, now you tell me when the inclination of the projectile becomes horizontal, at this point, okay, and also at this point. Okay, if R represent, okay, after t second, so it is given that after t second, what is happening? The inclination becomes what? it becomes horizontal. Now it is telling that what will be the value of theta if r represent the horizontal range, then what is the value of theta in terms of these values? Okay, try this question, take your time and try this question. Try this question, take your time. Try this question, you have to try. Try this question, you should try this question. Try once. Try this question, try this question. Just, I give you the hint. You know the formula of range is u square sine 2 theta by g. You know this formula? And also time of flight is given as time of flight, since here it is given t. Okay, the time of flight is given as 2uy. That is given, we can say like this. We should remember in shortcut like this: uy by g. And what is the uy? It is u sine theta by g. Okay. Now, if we are doing like this, okay, this is equation number 1. This is equation number 2. Solve these two equations. We have to find the value of what? The theta. Okay. Now, go through it. Go through it. How you will do? Try this. Try this question. Please try this question. Try this. You see here, you can see here from the equation 1. So let's see how we can solve it. You see here, range is equal to how much? It is equal to u square 2 sine theta. I am breaking the value of sine theta. 2 sine theta into cos theta by g. Okay. Now from here, u sine theta by g is time period t. Okay. Now from here, what we can do is we can take value of u from here. How much? It is equal to gt is equal to u sine theta. So we can replace the u like this from here. We will get r is equal to how much? G square t square, g square t square. Okay, g square t square by how much? It is equal to sine square theta. Okay, into 2 into sine theta into cos theta. Now sine square theta, you will cut it from here. Okay, g square, g is also present here, g cut here. Okay, now we will see here what is the range coming. It is coming like this. How much? See, 10 to 20, 20 t square. We can write like this: 20 t square by sine theta cos theta. We can write like this: tan theta. And my dear friends, you can see here sine theta, we can write like this. Okay, now we can do like this also. You can see here we can do like this also. We can do like this also. That is, tan theta is equal to 20 t square by r, like this. Okay, so theta is equal to how much? Theta is equal to how much? Okay, now in terms of cot theta, we are seeing the option in terms of cot theta also. We can write r by 20 t square. So cot theta, you will get how much you answer? Your answer will be D in terms of cot theta. Got it? Anyone, any problem till now? You can ask. Anyone, any problem? You can take the screenshot. Okay. If you have any problem, you can ask. Okay. Now, let's go to the next question. Next question. Okay. See, it is telling that a block of mass 10 kg is sliding on the surface with the initial velocity of this. Okay. It is not telling that the surface is horizontal or inclined. So, according to the question, this is the surface, and in this surface, a body is moving with a velocity of how much? Okay, and the mass of body is also given as 10 kg. It is moving with a velocity of 9.8 meter per second. Okay, and also given that coefficient of friction is equal to 0.5. It is asking that what is the distance covered by the block before coming to rest. Okay, we know if it is going some negative force, that is retardation force, will come due to the friction force, and we know that what will the friction force here, we can say it will be equal to mu into n, that is mu into mg. Okay, from here we can write like this also, that acceleration is equal to force by mass, that is mu into g. We can say acceleration is mu into g. Now we came to know that negative acceleration is mu into g. So now what we'll do, just we can apply the formula, that is v square is equal to u square plus 2s, but here retardation, so minus 2as. Okay, finally it will come to at rest, so u square, v square is 0. You put the value of u square, you can write like this, u square how much, 9.8 whole square is equal to 2 into a. A is how much, it is equal to mu into z. What is mu? Mu it is given as 0.5, and g you put here 9.8. Okay, into s. Solve from here. Okay, after solving it, you will get your answer, and what you will get your answer like this. Solve here, you will get your answer like this, 10. Okay, like this, 2 will cut here, you will get s is equal to how much, 9.8 meter. See here, your answer will be 9.8 meter. Any problem to anyone, we can discuss it once more. If we have any problem, we can discuss it once more. Anyone, any problem till now? Any problem? Okay, now let's move further. See, okay. Let me remove this. I think now the question is given. You should try this question. This type of question usually comes in your exam. Okay, and remember, whenever this type of question comes, it's very easy. Okay, so never get afraid from this type of question. These questions are very easy. You have to just balance the force. Usually this type of questions come in your mechanics section. Okay, or whenever mechanics is related with other chapters also, this type of questions comes. Okay, so never get afraid from this topics, this type of questions. Okay, so read the question, take your time, 30 seconds. Till then I take water also. Okay, read that question. What it is telling, that a boy ties a stone of mass 100 gram. Okay, a mass of a stone is given. Okay, okay, it is telling that a boy is holding a stone that is 100 gram. Center is here, it is holding here, and the string is 2 meter long. Okay, it is whirling it. It whirls it around a horizontal plane. What is meaning of whirl? It is meaning that it is doing a circular motion like this. See here. Okay, and remember, it is in horizontal plane. You remember horizontal plane and vertical plane? You must have read in your circular motion chapter that when we are doing under gravity, circle is completing under the effect of gravity, then it is a vertical plane circle. Okay, and if we are not considering, we are not we are not considering the value of the G, okay, then we perform horizontal circular motion, okay, that is in the plane of your table, that is horizontal circular motion, this type circular motion, okay. And it is also given that, you know, if a object is moved in a circular motion like this, you know what will happen. A centrifugal force will occur in it. How much? It will be equal to m omega square r, okay. And you know this centrifugal force will try to break the string, and this stone will try to go away from this circle due to the effect of centrifugal force. Similarly, on the other hand, what will happen? The string will apply tension force like this in opposite direction to balance this. And my dear friends, you can see here this value of the tension is given in the question, and the tension value is given as 80 Newton. You see here, it is given as 80 Newton. Okay, so it is telling that what maximum, and also it is given that the maximum speed of the string is given. See here, it is given as k by pi revolution per, I think it can be minute or second. I think it is revolution per minute. I think maybe per minute. Let us check. Between matching calculation may be mistake. Okay, typing mistake is here. So it is given like this. So we have to find the value of the k. Okay. So what we will do here? We just equate, because here maximum speed is given, and we will equate with the limiting case. Okay. So 80 Newton is equal to m. M is what? 100 gram. 100 grams means 100 by 1000 omega square. That means leave here omega only, into r. It is given as 2 meter. You see here, all values are given. You can see here. Okay. All values are given. You can see here omega will come like this. How much? It is coming like this, 20 revolution per second. Okay. Now it is telling that it is revolution per second. Okay. Now we know that, I can write like this. It is not revolution. I think it is radian per second. Okay. And we know like this. We also know like this. It is given in terms of k by pi. Okay. So we can write also like this. That is, this omega is equal to 2 pi f. That is 20. So f is equal to how much? 20 by 2 pi. That means 10 by pi. Okay. This is in terms of per second. So in terms of per minute, what we will do? We will multiply it by 60. 1 by 60 in the denominator, 60 will come in the numerator. We will get how much? It will be equal to 600 by pi. That means in place of k, what will the value of k? That will be 600. So our answer will be C. Anyone, any problem till here in this question? You can ask. Anyone? Remember, this type of questions usually comes in your exam. Okay? Usually comes in your exam. Whenever question comes, just apply the limiting case, compare the maximum value of the acceleration with the tension, or this question comes with electrostatics also, magnetic field, magnetic effect of current also. They're also same concept. Just equate the centrifugal force with the limiting force that is given in the question. Okay? Okay? So I think we should move to the next question. So let's move. I think first of all, okay. Now next question is here. See here. Next question. It is given like this. It is given like this. A vertical electric field of magnitude 4 point and value is given. just prevent the water droplet. See here, my dear friends, it is a type of question, Millikan's oil drop experiment, not expected. Millikan oil drop experiment. Okay, okay. We can't expect that this question can come also, because in Millikan's oil drop experiment, you will go through the NCERT or any book. They're just mentioning the name. They're not discussing about that what is the experiment about it. But you see here, the exact question of the Millikan's oil drop experiment came here. See here, oil drop experiment came here. See here, it is given that a vertical electric field. You remember? Let us suppose like this, a vertical electric field like this. Okay, it is present here, and the value of the E is 4.9 into 10 to the power 5. Okay, and also it is given like this, and also it is given like this. Thus, it is just prevents a water droplet of this much gram from falling. It is telling like this that it is balancing the, it is just balancing the what? A water droplet. Okay, a water droplet, just balancing the water droplet. Okay, from falling. Then what will be the value of the charge on the droplet? Okay, take 30-second time and try this question. Try this question, take your time and try this question. Just balancing. This is also the balancing question. Okay, this is also the balancing question. Okay, so try this. Try this question. Try this question. Okay. Okay. Now, what we can do like this, see here, what we can do, we are just balancing. Now, let us see the solution part. It is telling that we know that, since we know that the mg, due to which this drop will try to fall. Okay, the value of this mg. Okay, see here. Okay, the value of this mg, it will try to fall down with this. It is equal to what? The QE, that is the electrostatic force, which is going to balance it. Okay, you can see here. Now what we can do here? See here. Okay, they are balancing each other. Now we can put the values of the given. What we will do? The mass is given. How much it is given like this? 0.1 gram. So we put it in SI 1000. Okay, into G 9.8. So take 9.8. Q we have to find. Okay, Q, and E is given as 4.9 into 10 to the power 5. Just solve it. You will get the values of your Q, and the value of Q will be how much? Just solve it. I think we'll solve here. 10 will come here. 4.9 you can see here. This will go by 2. Okay, you can see this will go by 2, and the only factor will come 2. Okay, your answer will be. Okay, now you should remember this. What? One thing should remember this. This was the question of from Millikan's oil drop experiment, and you know, by the help of this equation, by the help of this experiment, Millikan's proved that the charge is quantized. You remember this? Other than this question part, I am telling now that by this experiment, Millikan's proved that charge is quantized. Okay, and we know we got the formula Q is equal to Ne. Okay, Should remember this. Okay. Any problem to anyone? Let's move further and see the next question. So now, no. Now, let's move further. Now, let's move further. See next question. Okay. Now, see next question. What is this telling? So, in the next question, we can see here, it is telling that a particle experiences a variable force. See, should remember few things. What I am telling that suppose this type of question comes in your exam. Okay, you know this type of question usually comes from this topic, that is from work done. When we are calculating the work done, we use this formula, and also in chapter of gravitation and in the chapter of electrostatics. 3 chapters you can get this type of question. Okay, so a variable force is given. Okay, why variable? Because in the terms x and y are varying here, because you can see here force is depending upon x and y. Okay, it is telling that all things are given as meter, that is SI unit system is given. A particle is moving from this point to this point. Okay, the kinetic energy change is how much it is telling. Okay, take your time. Okay, just use the formula of work energy theorem. One hint, work energy theorem. Use that formula. Okay, and I think you can solve it. Try this question. Try this question. Use the formula of work energy theorem. Use the work energy theorem. Okay, work energy theorem. Use this work energy theorem. Okay, now if we are talking about work energy theorem, let me tell you work energy theorem. What does it tell? Work energy theorem states that the work done is equal to the change in kinetic energy. Okay, so we came to know here the work done that we will do, it will be equal to a change in kinetic energy. So in the question we have to find the change in kinetic energy. We came to know here, if we will apply, if we will find the value of work done, we can find the value of change in kinetic energy. Okay, got it? Getting my point? So what we can do here is now what we can do here, we can write like this: work is equal to change in kinetic energy. Okay, work is equal to change in kinetic energy. So you can write like this, that change in kinetic energy is equal to work done. Work done means how much? It will be equal to force into displacement dr. That we know. Work done is how much? It is equal to force into displacement. Okay, try this. First of all, students should try this. Okay, try this, get your answer. Try this. Now, oh, some technical issues came. Okay, now we know that the kinetic energy is equal to the work done. One negative sign is there. Okay, now we can, to find the value of the work done, to find the value of the kinetic energy, we can write like this: it is equal to force into displacement, like this. Okay, now force, what is the value of force? It is given as 4x square I, so sorry, 4xi plus 3y square j into, for dr we replace like this, dx I cap and dy j cap in terms of differential position vector. Okay, now what we do, we separate it using dot product like this: 4x dx plus 3y dy, and then we put the value of x, that is from value of 1 to 2, limit from 1 to 2, and for y we put like this from 2 to 3. Solve this, you will get the value of your k, and after solving this, I think you will get the answer like this: 4 into x square by 2, okay, 3 into y square by 2, okay, and I think it was 4x, okay, 3 by, okay, it was 3y square, na? So y square, so y cube by 3, okay, put here value of your x, that is from 1 to 2, and put here the value of your y from where, from 2 to 3. Put all the values, integrate it, and you will get your answer, okay, and the answer will come out like this. See here, you will put here from 2 to it will get cancelled, 2 square you will get 4 from here, 3 you can cut from here, what you will put here, 3 cube 27 minus 8, and from here it will come like this. So we will add up and we will get here 24 25 2. Got it? Any problem? Just simple integration, and being a mathematics student you should know all this, okay. Now let me tell you apart from the question part, okay, this type of question usually comes to find the electric potential. At one point potential is given, and at another point you have to find the potential. What is the potential at this point? This type of question usually comes in your IIT, JEE advanced exam, okay, JEE main also. So be prepared for this type of question, and for solving this type of question these steps are common, okay. First of all, second type of question come from the chapter of gravitational, okay. From here also same type of question. A gravitational potential is given at one point and you have to find the gravitational potential at other point, okay. Same concept you have to apply here, so be aware from this, okay. This type of question may come in your upcoming exam also, okay. Got it? Anyone, any problem? So now let us go to next question part. Now it is given that it is given like this, the approximate height, okay. Now see here, it is telling that the approximate height of the surface of earth from which the weight of the body becomes 1/3 of its weight on the surface of earth. See here, it is telling that on the surface of earth something weight is, let us suppose W, when it goes to a height of some height, that is h, how much it becomes? It becomes W by 3. W by 3. Okay. Now, okay. We have to go fast, okay, but we will cover the important part also of each questions, okay. So what we will do, weight is from here to another point, weight is reduced by 1/3, and you remember weight is equal to mg, so we can write here it is equal to mg by 3. That means we can say what is happening, the value of g is decreasing from g to g by 3, that we came to know, okay. Now it is telling that what is the approximate height, this h we have to find, okay. So what we'll do, we know that the formula of g dash at a height when we are moving away from the surface, okay, at a certain height, we know that g is equal to r by r plus h into square. This is the formula for variation of g. You should remember this formula, okay. Now it is given here, see here, it is g dash is given as g by 3 is equal to g into r. The radius of earth is given here, see 6400, you put here 6400, okay, by 6400 into h you have to find g square, you can put here. Now for square you put there square root, you will get 1/√3, okay, or you know this, it is equal to r by r plus h. So you will cross multiply it and you will find the value of r. H. R is given. What you will do, and the value of root 3 is also given here. You can see here. Okay. What you will do, you can do right. You can do like this. Root 3 is equal to r plus h. That means you can write like this: h is equal to root 3 r. I can write like this: r into root 3 minus 1. R is 6400 kilometer. Root 3 value is given, you can see, and also you know 1.73 minus 1. Put all the values, you will get how much? See, will 0.73. Okay, now 0.73, and after solving it, 0.73 6400 into 0.73. Okay, you will solve where you will get 43. You will get your answer as 4685. Approximate answer. I think approximate not, will get this answer only. Any problem to anyone you can find, you can ask here. Any problem? So let's move to the next question. Okay, let's move to the next question. See here, it is telling that a resistance of 40 ohm is connected to a source of alternating current related to this. Now you remember these things. This question came from an alternating current, and you know that the value of the voltage it is given as, it is RMS value. Okay, it is telling that a resistance is 40 ohm. Okay, find the time taken by the current to change from its maximum value to the RMS value. Okay, now how we'll do this? See, you will draw a circuit. First of all, draw the circuit. It is given like this also. That is 40 ohm. See here, 40 ohm, and it is given as like this: 220 volt, 50 hertz. Okay. Now we can do like this. We can do like this here. What will happen? Current will go in the circuit like this. Current will go in the circuit like this. Suppose I. We know that is telling that find the time taken by the current to change from its maximum value to RMS value. Now let us compare the RMS value and the maximum value. If suppose this is the alternating current, okay, we know one thing. At this point we get the peak current, that is the maximum current. It is RMS, it is maximum current. And this at this point phase is how much? Pi by 2 for a sinusoidal curve, pi by 2. Now for a value of peak value, the RMS value, that is maximum root 2. Okay, we tell like this: at this point and this point. At this point, what is the phase difference? It is 3 pi by 4. Okay, so if we are discussing how much is the phase difference between the RMS value and the peak value, we can say the phase difference is 3 pi by 4 minus pi by 2. We can write like this. We'll get here pi by 4. Okay, we got the value of the pi phase difference. Okay, now what we can do here? Now what we can do here? We have to find what? We have to find the time. We will write like this: time is equal to how much? The displacement of the sinusoidal curve. Okay, that is the phase. How much it has moved from here to here? By how much? You remember that circular motion, time is equal to angular displacement by time, and you do remember this formula, that displacement is equal to angular velocity into time. You remember this formula? So we can write time is equal to this, that is the phase difference, angular displacement by omega. Okay, put here the value of theta is how much? Pi by 4, and the omega is coming from where? You see, that is 50 hertz. We can write like this: 2 pi into f is how much? 50. Solve here. pi cancel. Put here, it is coming as 100, 400, I think 0.2 like this. Okay. I think it will come like the millisecond, 2.5 millisecond. Okay. Any problem to anyone? You remember, you friends, this type of trick you should remember here. What? That whenever the questions come, calculation, you can see, observe the calculation. Never do the calculation and get your answer. From here, you can think also how much it can come. Okay. I came to know here that it will come like this. Okay. Got it? Now, apart from question part, what you can do? What type of question can come from here? Now, I tell you one thing, that apart from this question, remember, you should remember the given value is always the RMS value, not the peak value. Okay? And for the value of the, and we are given a peak value, we have to find the RMS value. We know the conversion formula, that RMS value is equal to the peak value by √2. That we know. Okay, I should go through this type of numerical from this chapter also. Okay, now let's move further and see next question. Now let's see this question. Good question. Okay, good question. So try this. It is given here. See here, y1 is given here, y2 is given. Two waves are given, y1 and y2. Okay, and these two waves, you see here, the amplitude of the resulting wave. These two waves, let us suppose they will interfere. Okay, superposition will occur. So we have to find the what will be the amplitude of the resulting wave. Okay, so to find the resultant of amplitude wave, amplitude of the resulting wave, we know the formula, that the amplitude is given as how much? It is given as like this. Okay, how much? It is given as a1 square plus a2 square plus 2a1 a2 a2, okay, into cos theta. That we know for our concept also. Okay, we use the vector addition, that we know. We use the vector addition formula. Okay, now to find the a1 a2, see here, a1 is given as 5, a2 is given as 2, 3. See here, only we have to find the value of the phase difference. What is the value of the phase difference between these two curves, between these two equations, between these two waves? Okay, try this question, take your time. Okay, you can see here, it is if you will see the observe the equation of both the wave, you can see here this part, that is wave is given like this, y is equal to a sine omega t. See here, a sine omega t kx in this pattern. Okay, you can see here these two waves are moving in same direction, so here interference can occur. You see here, there is some phase difference also. To find the phase difference, what we'll do like this. We will find the phase difference like this. It will be equal to how much? 2 pi into f. F is how much? It is equal to what is the phase difference. If you will subtract this factor from this factor, you will get a resultant of 1.5. You are getting what I am telling? X minus Vt plus 1.5 minus x minus Vt. Okay, you will get 1.5. Okay, that will be the value of your phase difference, 1.5. To find that into angle, what we will do, we will multiply 2 pi. We will get here how much? We will get here 3 pi. This is the value of theta. Okay, put the value of theta here. Okay, what you will get? 3 pi. That means pi, 2 pi, 3 pi. That means -1 will come here. Okay, and what will happen? It will become the formula of a1 minus a2. That means I think formula this means 5 is minus 3. That means square formula comes, that is a minus b whole square. That means answer will be 2. So just solve it. It will become formula of a minus b whole square. Okay, that means a minus b only. Okay, got it? So let's move to the next question. Let's move to our next question. Now let's go to our next question. Now, try this question. Try this question. All of you, try this question. Now, my dear friends, the question came from the chapter of electromagnetic wave. See here, the question is from the chapter of electromagnetic wave, and none of us can expect that a chapter from a chapter of electromagnetic wave question can be asked, because usually they never ask from this type of chapters, electromagnetic wave. But see here, a numerical has came. Okay, and if you will go to the NCERT book, numerical is given there. So I think NCERT is also important, okay, for the exam. Now, let us see what it is telling. Let us see. A plane electromagnetic wave is given. Here you see here. And the value of the magnetic field intensity is given. See here. Permeability is given as, see here. And the speed of light is given. Okay. It is telling us to find the value of the electric field intensity and what will be the approximate value of the electric field intensity. Okay, so please try this question once. Please try this question once. Please try it once. Okay, one hint. I am giving you one hint. Okay, see, you remember this formula? Speed of light, c. Speed of light, c. Okay, you remember this formula? Speed of light, c. It is given as 1 by under root. Now, let's see. In this question, what it is telling that, see here, relative permeability is given. See here, relative permeability, that mu r is given. See, relative permittivity, that is mu t, that is epsilon r is also given. Magnitude of the magnetic intensity, that is, we can say B is given, mu naught is given, C is given. First of all, we know the formula of C. C is given as 1 by under root mu naught into epsilon naught. This we know. Okay. For a vacuum, this is the speed of light, and it is related with permeability and permittivity like this. Okay. Now, in place of the speed of light, we are having the speed of light, speed of the electromagnetic wave in any medium, general medium. Then what we do? We put here like this, mu r into epsilon r. You know all these formulas? They are just a basic part. You have just used this formula only. Take ratio of this, all those given formula given here. What you will get here C by V is equal to how much? It will be equal to, I think some mistake I have done. Some mistake I have done. I think it is this. Correct. Okay. It is mu, it is epsilon. Now take the ratio of both of them. You will get here what? You will get under root mu r into epsilon r after taking the ratio of both of them. Okay. See, mu r is given, mu and epsilon r is given. See here, this is the value of mu r and this is the value of epsilon r. You can see here, this is the value of mu r and this is the value of epsilon r. See what we did, C by V is equal to under root mu r into epsilon r. From here, mu r is given, epsilon r is given. If you will put the values of here and the speed of light is also given, we can find the velocity of the electromagnetic wave in a particular medium. Got it? How you will do this? Speed of light 3 into 10 power 8 meter per second, and put the value of mu r. Mu r is also given here. You can see 1.61, there 1.61 and 6.44. 6.44. You will get certain values of the velocities. That will be the value of the velocity in case of any medium, general medium. And also we know that for electromagnetic wave, the velocity for electromagnetic wave is given as V is equal to electric field intensity by magnetic field intensity. The value of V you will get from here, put here, okay? And after putting the value of V here, you are also given the value of B. See here, put the value of B, you will get the value of your E, okay? And this will approximately come like this. I think answer will be C, 4.2. 4.2 10 to the power 6. Okay, just go through it, put the values, you will get the solution. Okay, I don't want to waste your time, precious time. Okay, so solve it. Any problem we can discuss. So let's go to our next question. Let's move and see our next question. See, I think it is a good question. Decision. Which of the following is a correct option? Okay, read the option. It is telling that in a ground state of the Rutherford. You remember the formula of that concept in Rutherford and the Bohr scheme. You must have read in your chemistry paper also. What you have read, that in a ground state of the Rutherford model, electrons are in the stable equilibrium, while in the Thomson model, first of all, see here, it is the wrong statement. You know, in our Rutherford model, it was not stable. That was the drawback of Rutherford, and it was cleared by Bohr. Okay. Okay. This is the wrong statement. Second statement: an atom has nearly mass distribution in a Rutherford model, but a highly non-uniform. It is having non-uniform mass distribution in Thomson model. Okay. It is telling that nearly continuous mass distribution. You know, in the Rutherford model, it was still that it's what said that it is a non-uniform also, because maximum mass and charged particle is concentrated at its center in very small radius, and maximum part is vacuum. You remember this? So we can say the Rutherford map, according to Rutherford model, atom was not uniformly distributed. Okay, so we can't say like this. So this statement is also wrong. The class C statement. The classical atom based on Rutherford model is doomed to collapse. This is the correct, because it was the drawback of Rutherford. Okay, and C D also, let us check it. The positively charged part of an atom, most of the mass in the Rutherford model, but do not it is wrong. Now that is telling that in the Rutherford model, what it was told, it was said that the center has a concentrated positive charge, and the electron, that is negative charge, it just rotates in the orbit around this nucleus. Okay, now this was wrong. Now C part, it is telling that, now let us explain the C part, that according to the Rutherford, electron will rotate like this and it will collapse according to the electrodynamics principle. Now, according to the Rutherford model, if the atom is the nucleus is if it is electron is rotating, revolving around the nucleus, what will happen? It will radiate energy and will fall in the nucleus. That was the according to the principle of electrodynamics, and it was overcome by the Bohr-Buddy scheme, Bohr-Buddy model. He told that what, that in an atom, the Orbit is a discrete, a fixed energy level. It doesn't radiate any energy. That you know. These things I am telling apart from the question. Okay, so you should remember this. Okay, now let's move further. Let's move further. Next question. Next question. See, read this question. Read this question. Read this question. It is telling that, see here, according to the question, it is telling that a nucleus A is having a mass number of 220 and its binding energy per nucleon is given as 5.6 mega electron volt. Okay, it is telling that a nucleus A is telling that, see here, it is telling that, okay, now see, it is telling that in orbit A, see here, see, it is telling that a nucleus A, okay, it is having a mass number of how much? 220, okay, and binding energy, see here, binding energy per nucleon, it is given as 5.6 mega electron volt. It splits into two parts, that is B and C. B and C. And their mass number are also given. See here. B and C. Okay. Mass number is also given 105 and 115. That means these are reactant and these are product of the nuclear reaction. So if we will add up these two, we will get how much? I think we will get the 115 now. We will get how much? We will get 120. Then we will add it up. We will get 3. I think we will get here how much? We get it here like this. There will be, we will find what is the energy difference between the product after the nuclear reaction and the nuclear reaction and before that nuclear reaction. So we can write Q, equation of the Q in the nuclear reaction. We can write like this: binding energy of product minus binding energy of reactant. Okay, binding energy of product is how much? You can see product 115, here 115 and 105. There is a mass number per nucleon, total nucleon, and it is also given binding energy per nucleon. So we have to multiply it with the binding energy per nucleon. You see here, the binding energy per nucleon is given as 5.6. So we will multiply here with 5.6. Okay. For B and C, it is given as 6.4. We will multiply here with 6.4. Okay. 6.4. Got it? Now, if we are talking about the reactant part, we will do like this. How we will do like this? See what we will do. See what we will do. We will put here minus sign. Okay, minus sign. Then reactant 220 into binding energy per nucleon is 5.6. Solve it. We will get value how much? We will get here 220. Okay, 220 into 6.4 minus 220 into 5.6. Solve it. We take 220 common. Okay, 6.4 minus 5.6. Solve it. You will get value of 176. That will be 176 mega electron volt. Got it? Any problem to anyone? We are not wasting time in solving and getting the answer. I'm just telling you answer. You can do it and you can go through the solution part. Okay.